Hi, class. So this would be the last of chapter 8, finally. And so I decided to do a problem right from your Alex homework. And so let's just jump right in and do that one. And it'll be a good review of what I just talked about in the previous recorded lecture. And here's my recommendation again on how to do this. So this one says, it's question 4, eat your cereal. I'm a cereal fan, so I like this one. Boxes of cereal are labeled, and each contain theoretically 18 ounces. And so there was a sample of 12, and here's the data. And the first question is find the sample standard deviation. So again, the beauty of why I like Alex here a little bit is you can see it downloads it right to the spreadsheet for you. And I'm like, that is awesome. And so here are our values. And so let's label this. So this would be the sample standard deviation. So SS standard deviation, SSD, there's our standard deviation. And so you would come up to more functions. We don't even need to calculate the mean, right? Because the idea is that it should be standard deviation dot S for sample. Click on that. And up comes the function. And we're just going to use the first. So you highlight this. You hit OK. And up comes the standard deviation of 0.07 and some change. Let me see if I can make that a little bit bigger. There we go. 07 and some change. And so if we take a look at what they're asking for here, it says round to 4 decimal places. And so what I would do is I would take this and hit format cells by right-clicking my mouse. And when you go to numbers, just let it do the math for you. So that number should be 0.0736. Sample standard deviation, pressure's on, 0.0736. Yay. So let me get to the next section, right? And so here's where we're doing our confidence interval with the standard deviation aspect of it. And it says round the answers to at least 2 decimals. So what is the first step? Well, we have a 95% confidence interval, right? And so we need to find those 2 chi values, right? And so you go to the table, and our degrees of freedom is 11. So that's the n minus 1, which is 11. So you go to 11, and since it's 95, high n is going to be 3.816. And so that would be the 0.975, right? And the low end is going to be this 21.920. So remember, those are our 2 tails, low end and high end. And you can see they're not symmetric around the middle there, as we talked about before. So that's the first step. So what's next? Well, let me pull up, whoops, wrong. Let me pull up the whiteboard to show you the formula again. So the formula is this: n minus 1 times s squared divided by that chi thing. And so what is s squared? That's our variance. So what did we calculate? Standard deviation. So what we'll end up doing is this will be 12 minus 1. And our standard deviation is 0.0736 squared, right? And then we divide it by these 2 numbers. 816 would be the high end, and 21.920 would be the low end. And so the way I would do this is, since I've had the spreadsheet out, I would let the spreadsheet do the arithmetic for me. Let's see if I could do this right. And we're going to do 2 decimals. So here's our standard deviation, right? So let's do the lower bound, right? So what we want to do is equal sign, and then 12 minus 1 is 11. So I'll just type in 11 there, right? And then what we want to do is we want to take this number and square it. So it'd be shift 6 squared. And then what do we want to do? We want to divide by the lower bound would be the high end of the chi-square number, which was 3.816. And it didn't work right. There we go. What did I do wrong there? I think I might need, let's see here, just double check and make sure that's the same answer. Yep. So at the lower bound, it's 0.01, which is quite a bit lower than 0.07, right? And then what about the upper bound? I'm sorry. That is the upper bound. I did it backwards because I divided by the small number. So the lower bound is the big number. That's going to be that 21. And so here, just let me show you. So you always divide by the lower number to get the upper bound, and then you divide by the bigger number to get the lower bound. And I obviously plugged in the lower number first by accident. So what did I do? I'll just relabel it, right? And so let's do the lower bound. And so this one, again, would be equals 11 times, again, the standard deviation squared, which is the variance, right? And then now we want to divide by the 21.92. And so you can see that that lower bound is quite a bit smaller, right? And so that would be 0.0072. So the big question is, what is our variance, right? What is our variance? And so let's take a look at that number. So if we, how we do that is that we'll just take this number here and square to do a quick comparison. And you can see I didn't do anything with that. So the variance here, right, here is 0.0054. And so the upper bound is 0.015 and the lower bound's 0.002. So you can see it's not in the center. Remember that, it's not going to be in the center with the chi-square, right? So now we have the plus or minus variance. And so it wants the standard deviation, right? So how do we do that? We take this whole thing and take the square root of it. So to do that, I just do equals. You could use the square root function. I'll just do shift 6.5 and you get 0.125. And then do the same thing for this one. Take the square root and you get 0.05. So you could see that the upper end is an eighth and the lower end is down. So the upper end goes up more than the lower end goes down. And so the next thing is type in these values here. And so what do we get? It says round your answer to at least 2 decimal places. So the lower end would be 0.052 and the upper end is 0.125. Yay. So kind of annoying, but it if you just kind of walk through it step by step. You can do this by hand too, right? You could have plugged that all into your calculators and do those calculations. But I thought since the spreadsheet's out, I thought it would be nice to show you that you could use the spreadsheet as a calculator as well. I do all the time. And once you get good at it, you'll find that it actually goes pretty quick. especially since you can cut and paste numbers into equations, et cetera, really quite nicely. And so let's see what this says. So it says, the goal of the quality control manager is that the population standard deviation of the weights is to be less than 0.16. And so based on the confidence interval, is this reasonable to believe that the goal is met? So what you want to be less than, right? So you're worried about the high end. And what's the high end in our confidence interval? Well, our high end's only 0.125, which is quite a bit less than 0.16, right? And so if you think about it, that for a 95% confidence level, that's going to be our highest standard deviation. And I think that the quality control manager has met. So this would say yes, because all the values in our confidence level, and obviously if you look at the high end, right, is less than 0.16. So I hope that helped, walking through one of these problems directly from the Alex program. So that ends the recorded lectures for section 8.4 and actually all of chapter 8.